let me record this. Right, so that means that x2 is equal to 5 and y2 is equal to -6. Next step, could anybody tell me what's the next step? Anybody, what's the next? What's the next step? Okay, let me just tell you. Then you want to find m. So we know the formula y2 minus y1 over x minus x1. So just okay, right? Third step, we just sub in those values, right? So y2 minus y1, looking over here, y2 is -6. So I got -6 minus y1. y1 is 7. x2, 5. I put my 5 there, minus x1 is -4. Remember the brackets, it's minus 4. -6 minus 17, that's -13. 5 minus -4 becomes 5 plus 4. So that's -13. 5 plus 4 is 9. And that's how we got this answer. So everybody understands that?
Yes, miss.
Right. Oh. Actually, let me write it. This is the same question. Just want to remind you something. 5 minus 6. So before my x1 and y1 was this coordinate right here. And then x1, y2, this coordinate. But remember, it's interchangeable. So if I wanted to, I could put x1 is equal to 5 and y1 -6. And then x2, oh my, is equal to -4 and y2 y2 is equal to 7. So just remember that. Hold on. Right, so remember x1, y1, x1, y2 are interchangeable. So now, put the formula here again, so nobody's confused. M is equal to y2 up to 2 minus y1 over x2 minus x1. So now, instead of having -6 minus 7, 7 is now y2. So what I would have is 7 minus -6. And now instead of 5 minus -4, I'll have -4 minus 5. So 7 minus and a minus is a plus, so 13. And then -4 minus 5 minus 9. I just wanted to remind you that. Okay. So say I have the gradient m is equal to 5. And I have m is, oh my God. And I have m is equal to 1/2. Can you tell me which line would be steeper? If I have m is equal to 5 and m is equal to 1/2, which line would be steeper? Anybody remember?
M is equal to 5.
No, I asked which line is steeper. Okay, so let me remind you. So as m increases, so as the gradient increases, steepness, S stands for steepness, right? Steepness also increases. And as m decreases, steepness also decreases. So now what I'm asking, looking at 5.5, the gradient is 5 and the gradient is 1/2. So which line would be steeper? It's the value, the greater value. So,
5.
it's 5. Right, so yeah, the steeper one would be the gradient with 5. They wouldn't test you on that. I just wanted to let you know that. Okay. So this is my y-axis. Y-axis. This is my x-axis. And this is a line going uphill. Going uphill. Can you tell me what would be the gradients of this line? Would the gradients of this line be positive, negative, 0, or undefined? The line is
Positive.
going uphill. Positive.
Positive.
Good job. Good job. So M would be positive. And if I had the line going downhill, so downwards, X, Y, and my line was going this way. This way. Positive, negative, 0, or undefined?
Negative.
And it's negative. All right. Oops. That's XY. I have a vertical line. XY. And a horizontal line. Tell me which one would have a gradient that is 0 and which one the gradient would be undefined.
The first one will have a gradient of 0.
Wait, repeat.
The first one will have a gradient of 0.
The
No.
first one will have undefined gradient, and the second one will have a gradient of 0.
Undefined. Yeah. And this one will have a gradient of 0. So remember that. Okay. Everybody understands this, right? This is just something to memorize. So uphill, positive gradient, downhill, negative. Actually, it wouldn't even look like that too much. If it was a negative gradient, it would look like this. Go down this way. Right. Okay. Could anybody tell me what's the general equation of a line? Of a straight line?
Y equals mx plus c.
Y is equal to mx plus c. Good job. And if my line is passing through the origin, so that's my x and y axis. And my line, this is the origin here, the point where the x and y axis intersect. And my line is going like this. What would be the equation of this line? It wouldn't be y is equal to mx plus c. What would it be? Anybody? All right, well, let me tell you. It would be y is equal to mx. Y, C right here. C is called the y-intercept. And the y-intercept is wherever the line touches the y-axis. This is my y-axis. And this is my line. This line does not touch the y-axis, and that's why it doesn't have a C. But if I had a line like this, here it touches the y-axis. So this line does touch the y-axis. And that's why my equation for a line like this, because it touches the y-axis, well then y is equal to mx plus c. So you understand why this one doesn't have plus c, but this one has plus c? Yes, no, maybe, kind of, a bit unsure. Let me know.
Yes, miss.
Okay. All right. So another question. We almost finished here. So say I have a point 2, not a comma, 2, 5, and they give me the gradient. So m, remember the gradient could be denoted by m is equal to 3. And they asked me to find the equation of the line. Anybody remembers what's the first step? We'll do this question together. Can anybody tell me what's the first step?
To identify what is x1 and y1.
So x and y. X, y. So what's x1 and what's y1?
It's x1 and 5 is y1.
And 5 is y1. Y. Anybody remembers what's the second step?
Identify the gradient.
Identify the gradient. So m. M is equal to a question mark. That's what I'll put to identify the gradient. And they already gave us the gradient here, so we don't need to calculate it. M is equal to 3. Okay, third and final step. Anybody remembers?
Plugging the values into the equation of a line, straight line.
That's one way. Hold on, let me just do this way and then we'll go through the other way. So y is equal to mx plus c. We know y is 5, so we put 5 there, is equal to m is 3, x is 2, plus c. We find for c. So 5 is equal to 3 by 2 is 6, plus c. That means that c is minus 1. And the equation of this line is y is equal to, go back, m, 3x minus 1. So if they wanted me to find the equation of the line, this would be my answer. That's only one way to do it. Anybody remembers the other way?
Let's we can use y minus y1 equals m open brackets x minus x1.
X minus x1. So whichever way you think is best for you, you do that. Let me do that m. So what I would do, I would put back the y. y1 is 5. So y minus 5 is equal to m. M is 3 in brackets. Go back the x minus x1. x1 is 2. And now you just simplify to make y the subject. Simplify and transpose to make y the subject. So y minus 5 is equal to, we could expand these brackets. 3 by x is 3x. And then 3 by minus 2, minus 6. Add 5 on both sides. So y is equal to 3x minus 1. Same answer. So everybody understands?
Yes, miss. Yes, miss.
Okay. If they gave me, it's the same example from last time. So it's this. And we found that the gradient m was equal to minus 15 on 9. If they wanted me to find the equation of this line, what would I do? Actually, no. Find the equation of the line and tell me what you get. Anybody has an answer for me? Anybody has an answer yet?
Say it negative 11 or 9.
Like you got y is equal to this. I want the equation of the line. Eh? Oh man. That's what we're looking for. The equation of this line. And remember the equation of the line is uniform y is equal to mx plus c. So this is what you got. This. This was your answer. All right, I'm gonna just go through it then. Right. So let me use the second method. Y minus y1 m x minus x1. Put back the y minus. I want to choose this coordinate. I want to choose this coordinate. So my y1 would be 6 m minus 1309 x minus x1 5. Y minus 6 is equal to, expand these brackets. I could expand these brackets to get 13 on 9x, because 13 on 9 times x, 13 on 9x. 13 on 9 minus 13 on 9 times minus 5, minus and a minus is a plus. So I end up with, okay. Hold on now. Let me choose the others. Here's all this, here's all this, here's all this. Use this one instead. So y, for back to y, minus y1 is 7 is equal to m minus 13 on 9 x, for back to x, minus x1. It's minus 4. remember that, minus 4. Y minus 7 is equal to minus 13 on 9. A minus and a minus is a plus. So that's x plus 4. Y minus 7. We could expand these brackets. So minus 13 on 9 by x is minus 13 on 9x. And then minus 13 on 9 by plus 4 is minus 52 on 9. Of course, I don't have enough space. Look up here now. So what we want to do, transpose to make y the subject of the formula. So we add 7 on both sides. That's 7. Y is equal to minus 13 on 9x plus 11 on 9. That's if they wanted it in the form y is equal to mx plus c. Anybody got that answer? That was a yes. Okay. All right.
How the gradient would do using those points is supposed to get minus 13 over 9.
When
Because
finding the gradient.
Huh?
Ah, I see. I wrote down the wrong question.
yeah,
Minus 6. Oh, thank you. So y minus y1 equal to m x minus x1 y minus 7 is equal to minus 13 on 9x. Me no, skip anything. Minus 4 y minus 7 minus 13 on 9x. That's a plus 4. So minus 52. Wait, why did I even do? Anyways, that was a waste of time. We're gonna. Okay. Okay, sorry about that. Yeah. Okay, equation of a horizontal line. Let's pick back up the pace after all of that. So y-axis, x-axis. My horizontal line is in red. So see my horizontal line is this one. We already said that the gradient of a horizontal line is equal to 0. But what I want to know now, what is the equation of a horizontal line?
y equals c.
Y is equal to c. Good job. Y, x-axis, vertical line. We already know that the gradient is undefined. So let me just put on C. Right? And what is the equation? Actually, I have to tell you something about this. Okay, what I told you last class, x is equal to c. But let me clarify one thing. C in this case, c is the y-intercept. So like I said, y-intercept is wherever the line is my y-axis. The y-intercept is wherever the line cuts the y-axis. So, okay. This point right here, that's C. But then you might get confused because this line does not touch the y-axis. So in this case, C means y-intercept, but in this case, it just means a constant. So instead of putting x is equal to c and confusing yourself, you could put any other letter. So say I wanted to put x is equal to z, where z is just a constant. So I could put x is equal to a, b, c, whatever. So in this case, c means y-intercept, and whatever letter here, that's just a constant. So I look at my x-axis. Say this point right here was 8, and so it would have been x is equal to 8. I just need to clarify that. Okay, so c, in this case, y is equal to c, means y-intercept, x is equal to any constant on the x-axis. So everybody understands that?
Yes, miss.
All right, now time to start new stuff. No, that's what we did yesterday. That's what we did, that's what we did. I changed it here. So x is equal to z. Z is only a constant. Instead of z, any other letter could be used. So A, B, H, Y. Actually, no, don't put Y. But any other letter. Okay. You could leave and rejoin because we only have a little over a minute left. And that's not enough time. Okay, so leave and rejoin.